Hi, hello students. Welcome to Let's Understand Physics. Please like, share and subscribe for more concepts. Now we'll discuss free body diagram. Free body diagram means a diagrammatic representation of forces acting on the body. It is forces acting on the body, not by the body. You are not supposed to take the forces which are acting by the body. It is only to represent the forces acting on the body. So while drawing you have to remember this point, and here you can isolate the system or any part of the system from the surroundings, and you will be identifying the forces acting on the body, and it is very easy to represent. Okay, by using this diagram it is very easy to solve the problem as well. So free body diagram, you will have questions based on pulleys and block on block, connected blocks and blocks connected with the strings. All these examples you will have. So first we'll just see a simple diagram of a block placed on the surface. If example I am taking, the surface is smooth surface. Okay, so smooth surface means friction is equal to 0. You are not supposed to consider friction. There is a block of mass m. It is just placed on a surface. What are the forces acting on this? As the block is in contact with the surface, there will be normal force acting on the block by the surface. Okay, so normal, remember when I am telling normal, it is 90° with the surface. It is useful everywhere in physics, even in mathematics. So try to remember, when I say normal, that means it is 90° with the surface. So here normal force will be making 90° angle with the surface. So here just a free body diagram, how do you draw? You will take mass and you will just show normal force outwards from the surface. Okay, 90°. This is N. Instead of smooth surface, if I take rough surface, then mass is same M. Rough surface you have to take friction. Okay, frictional surface. Here no friction. That's why only one force we have taken. Now friction is always parallel to the surface and it acts in the opposite direction for the relative motion. Okay, it opposes the relative motion of the body. Frictional force always acts parallel to the surface and it is opposite to the relative motion of the body. It opposes the relative motion of the body. Okay, so here let us consider the force acting on the body is in this direction. So frictional force acts opposite to the actual net force. Now free body diagram you have to draw. Mass and normal force is acting. Normal force acts perpendicular to the surface and friction force acts opposite to the net force. Small f is representation. So other than these forces, there is gravitational force acting on the body. Don't forget, always on every body there is gravitational force acting. So gravitational force is a force which keeps the body on the surface. Okay, so how gravitational force acts? It always acts vertically downwards. Vertically downwards means for the surface, even this force acts vertically. Okay, understood? Normal force always makes 90° angle Gravitational force is vertically downwards. So gravitational force is represented with letter W. So here we call it as weight. Weight is equal to mass into gravitational force, means acceleration due to gravity. So gravitational force means the force with which earth pulls us towards the center of the earth. We call it as weight. Okay. Understood always? Sorry, understood? Gravitational force is a force which pulls us towards the center of the earth. So, weight we will get by multiplying mass and acceleration due to gravity. Okay? So, weight acts vertically downwards. Even in this case, weight acts vertically downwards, and force, whichever direction they have given, we have to consider that direction only. So, this is the free body diagram for this particular block. Okay, like this you will have pulleys question. So, let us take pulleys. I am just considering one pulley which is fixed on a rigid support, means the support is not moving. Even pulley is fixed to this support, so that only pulley will be able to rotate, and here we consider massless and frictionless pulley for our convenience. Okay, to make our situation simple, we just take massless and frictionless pulley. In the same way, there is a string attached, or string which is coming over the pulley. Even this string is also massless and frictionless. Okay, understood? Now here two masses are hanging on both sides. Let us take M1 and M2. Here you will have on the surface, if you have, there is normal force acting while contact, isn't it? Now when the masses are hanging on the string, there will be tension force acting. What do you mean by tension? Tension is a force which is exerted by the strings or ropes or wires, cables, anything you can consider. So that force we just take it as tension. So tension always acts away from the point of contact. Now this is the point. It will be acting away from the point. If I consider this point, from this point also it acts away from the contact. Even here, this side, and here also this side. As I am considering massless and frictionless string, tension throughout the string is equal. Tension throughout the string is equal. So this is also for our convenience. Like this, there are no strings, there are no pulleys existing. String is equal. Okay. Now if I consider M1 is greater than M2, tell me what happens. You might have seen pulleys, yes or no? So there are two weights hanging both sides, and when it is free, just suspended, then what happens? When it is released, whichever side you have more weight, that side the weight will be pulling the other weight, yes or no? So here if I consider M1 is greater than M2, that means here the acceleration of this M2 will be upwards and M1 will be downwards, isn't it? All of you understood? This is very important. As I have considered M1 is greater than M2, acceleration of M1 is downwards and acceleration of M2 is upwards when this system is released. Now you have to draw free body diagram for both M1 and M2 separately. So FBD, free body diagram for M1. Now see here, M1 is the block. Now what are the forces acting? There is no contact surface, so there is no frictional force. Here only string is there. String will exert tension force, and in which direction you have tension force? Upwards. Yes or no? Upwards. And what is, when mass is there, there will be gravitational force acting. Let us take, this is W1 because it is mass 1. W1 will be equal to M1G. Now acceleration is downwards. That means F net is downwards. Yes or no? F net is equal to MA, that you know. As I am doing for M1, it becomes M1A. So here acceleration of both the blocks will be equal because it is same system. FBD for M2. So M2, same forces, tension will be acting upwards and weight of the body will be acting downwards, M2G, and acceleration is upwards. This is very important to take the direction of acceleration, and in these cases we have to take uniform acceleration and identical acceleration or same acceleration for all the blocks. Okay, this is the simplest form. That's why these are the constraints you have to consider while doing. Now see here, from Newton's second law, F net equation we have to frame. F net gives you in which direction the bodies will move. Okay, for the first body, as acceleration is downwards, you can understand this W1 is greater, isn't it? W1 is greater, and W1 and tension, both of them are acting in opposite direction, so that you have to take the subtraction of the forces. W1 minus T equal to F net. So W1 minus T is equal to F net is M1A. In the same way, FBD of second body we have drawn and equation we will write. Okay. Now here acceleration is upwards. That means which force is greater here? Tension is greater. T minus W2 is equal to F net. So T minus W2 is equal to M2A. So I'll just take, this is equation 1 and this is equation 2. Okay, we'll just simplify these two equations. I'll write again. Here W1 minus T is equal to M1A. W1 also we know. W1 is M1G minus T is equal to M1A. And let us take, this is equation 3. And for second one, T minus W2 is equal to M2A. You know W2 value also, which is M2G is equal to M2A. Okay. So you can simplify or solve 3 and 4. Okay. Now M1G minus T is equal to M1A. I am writing M2G plus T is equal to M2A. Is it fine? I have just changed because minus T plus T I can cancel. M1G minus M2G is equal to M1A plus M2A. Now you can take G common. M1 minus M2 is equal to, you can take A common, M1 plus M2. So A is equal to, acceleration will be equal to G into M1 minus M2 by m1 plus m2. So by using this formula you can find acceleration value. So substitute this acceleration value in any of the equations to find tension. Okay, so equation 5 in 3, I am substituting in equation 3. m1g minus t is equal to m1, in place of a I am writing g into m1 minus m2 by m1 plus m2. Okay, so send t this side and this is this side. Understood? m1g minus m1 m1g m1 minus m2 by m1 plus m2 is equal to tension. Now take LCM. m1g into m1 plus m2 minus m1g into m1 minus m2 by m1 plus m2 is equal to tension. This is just mathematical simplification. Okay, so that you will just get final formula to find tension. So here also again you can take m1g common, so you will get m1 plus m2 into minus m1 plus m2 by m1 plus m2, or just multiply, you will have cancellations. So as I have taken m1g common, so m1g is taken common, m1 plus m2 plus into minus m1 plus m2. This minus I have written here. Instead of this you can write here also, and you can write m1 minus m2 also, no problem. Otherwise you can take just direct multiplication so that you will understand. It will be easy to cancel as well. Okay, any of the methods you can use. So we will just solve this equation. Now see here, m1g into m1 plus m2 plus into minus minus m1 plus into plus plus m2 by m1 plus m2, t is equal to, so m1 gets cancelled, t is equal to m2 plus m2, 2m2, so 2m2 m1g by m1 plus m2. So if you write t is equal to 2m1 m2g by m1 plus m2. Okay, this is tension formula. This is acceleration formula. So by using these two formulas you can find acceleration of any of the blocks whatever they give, or both the blocks only generally they will ask you, and tension in the string. Okay, so some constraints also I have explained to you. This is the simplest form. After that you will have block on block connected blocks, means on horizontal plane if the blocks are connected with a rope. So these are the models. When you go for +1 intermediate first year or PUC first year, you will have inclined planes. During inclined planes you will have normal reaction. You know already it is making 90-degree angle to the surface, and gravitational force is always vertically downward, whether it is inclined plane or horizontal plane. Okay, or vertical plane, any plane you can consider. So we will discuss all those types also in detail later. So this is the basic model. Based on this you can have questions. So you have a mass like this, and there is a pulley. If a person is pulling this pulley of mass 80 kg, how much mass he can pull, they have asked. So the tension will be equal to mass of this man into gravity. So mass only, if they ask, whatever mass the person has, the same mass only he can pull. Okay, this question is there in the textbook. So whatever mass they have given, the same amount of mass he can pull to the other side. Okay, next we will see when the two blocks are connected like this. Here is the pulley and one block is like this. So M1, M2. Okay, if acceleration is given downwards here. Okay, by acceleration you will understand M2 is greater than M1. Okay, so in this case, how do you draw free body diagram and how do you get acceleration value and tension developed in the string? We'll see in the next video. Okay, thank you so much. Please like, share, comment and subscribe for more videos. So if you want any other concepts, please comment and let me know so that I will try to make video on that concept. Thank you.